lists available. Like each country, they have their own material lists. So we'll go for India. Steel section database will be Indian. The steel design code, as we all know, is IS 800 2007, and concrete design code will be IS 456 2000. Now, once I press OK, we'll come to this new model quick templates. Now, inherently, the software will give you some predefined templates with which you can work. Right. One is the blank template. The blank template will not have any grids, or it will not. If you select the grid only option, you'll be having grids in the X and Y direction, which is used to model the structural elements properly. Okay, then there is another option of having a steel deck. Steel deck templates are also available in the software. You don't need to model them externally. You can use this steel deck template available over here. Then you have staggered truss. Similarly, flat slab, then flat slab with perimeter beams. Then you have a waffle slab system. And then a two-way. The last is the two-way or rib slab. Right. I hope you're once we go to the later part of the training session, you'll be able to understand what all these truly represent. Firstly, I'll be firstly defining some grids in the software. Okay. Grids is basically lines in both the orthogonal directions that is used to locate your modeling elements. Okay, first I'll go with the X direction grid lines. I'll give 5 grid lines and then 5 grid lines along the Y direction. And spacing, I'll keep them as 4 meters. You can also go for custom grid spacing. That will show you later on. Okay, then this is the simple story data. Now, when we are modeling a building, we are doing 3D modeling. So we need to model the story heights as well. Right. The software inherently gives you a bottom story height, which is meant for the founding depth or the foundation depth. Right. So this is normally different than the other story heights. So I'm keeping it as 1.5 meters. And the typical story heights, I'm keeping it as 3 meters. And the number of stories as 5. Now, once I press the OK button, you will see that there are 2 windows over here. One is the 3D view of the grids, and another is the plan view. Now you see that there are 5 grids along the X direction and 5 grids along the Y direction. And similarly in the 3D, you can see that 1, 2, 3, 4, 5. 5 floors have been created. 5 stories, in fact. And in this window, now you see that all the commands are not available over here. You need to go to the tools, the options button and reset the default toolbars. Okay, so all the toolbars will now be coming. Okay, now you see that all the commands have become activated now. The file menu is actually for working on the file. If you have to open a new model, either open another model, already saved model, then to save as, then you have the import option, then you can export from here, you can export text files, you can export files for the foundation also. Okay, then the report creation, printing graphics, all these commands are here. Next is the edit. The edit command is used for editing the elements that have been already created in the model. Okay, this is only for information. Once you use it in some model, you'll get to know how it is working. Next is view. This is for getting different views like 3D view, setting plan view, setting the elevation view. Okay, then setting the building view limits. These are the different viewing options that are present here. Then the define command. The define command is basically used to define your materials, the frame sections like the columns, the column dimensions, the beam dimensions, then the slabs, the slab thicknesses. Okay. Then also to define your loads that you're applying, like the dead loads, the live loads. Okay. Even for the earthquake loads, the wind loads, these things these things will be available in the define command. Next is the draw command over here. The draw menu. The draw menu you'll be having options for drawing joint objects, for adding joints, for adding beams or columns, then for drawing 2D elements like slabs, which are to be drawn in the form of floors over here. Okay, we have a different drawing options over here as well. Okay. Next is the select command, a select menu. The select menu is used for selecting things out of a model. Okay. If you want to have a very particular selection, like you want to select only the columns or the say the slabs, this can be used. Or you can say you can even select items using the material properties that we have defined earlier. Okay. Then assign. Once you have defined your model, like you've defined your columns, your beams, your slabs, your loads, you need to assign them using these. Okay. You can assign your frame properties, the column sizes, then you can assign the loads, the dead loads, the live loads coming on the frames through the frame loads command. To the shell loads command, you can assign them on the shells meaning the slabs or the horizontal floors, or even the vertical walls as well. And this is the analyze button. The analyze button will have your analysis options over here. Then this is the display. This menu will show whatever results you have or whatever loads you have assigned to the structure. To view them properly, you need to go to this display menu. Next is the design menu. The design menu will be used basically for designing the frames or the slabs. Okay, you have different design options over here: the steel design, concrete design, the composite beam design, composite column design, steel joist design, shear wall design, steel connection designs. Okay, then we have the detailing, and then we have the options. These options can be used for viewing and also for creating your models, creating and then changing your views. Okay, all these commands are also available alongside along the left vertical line over here, and the topmost and the third row over here. All right. So once we have defined the grids, the first thing that we need to do is define the material properties. Okay. We go to the define menu, go to material properties. Right. Now the software has some predefined materials as well. We'll define them according to our need. Okay. So we go to the add new material. We have the region over here. The region will be selecting India. Say I need to define the concrete properties first. So I'll go to concrete. Then we have the Indian. We can also define user-defined concrete as well. We'll be going for, say, grade M25. Select OK. Now you have the material name over here that is being defined. This can be changed according to your need. I'll say M25, say, for columns. Okay, the material type is concrete. And then you have the weight per unit volume over here, the mass per unit volume, the modulus of elasticity that is there in the code, that is 5000 under root FCK. It is automatically calculated and used here, which can be changed if you want, if you wish to. Okay. The weight per unit volume will be 25 kilonewton per meter cube. I'll make it exact and then I'll press OK. So I've defined one material, M25 columns. Now I'll define another material over here, which will be M25 for the beams. Sorry, I'll be defining M20 now, which will be for the beams. You see that the program automatically calculates it. You can check it. You can check it in your calculator as well. This is the value that comes from the IS code. Okay. Now once we have defined the grade of concrete for the columns and the beams, I'll be defining the rebar material. So from this material type drop-down list, I'll go to rebar, and the software gives us 4 different types of rebar materials. Now, if there are some rebar materials that are new to the market, which is having a higher grade than this, we can use user-defined as well. And in that case, we'll have to change it to user. Okay, I'll go with the predefined material list. I'll go with HYSD 500. Okay, now you see the material properties given here. These are already predefined. I'll press OK. Okay, so now that we have defined the materials over here, I'll close this menu and go to the define section properties list. First, I'll define the frame sections. Okay. Now, in the frame sections, I'll go to add a new property. Now, in this menu over here, the software gives you a list of predefined shapes and materials. Okay. You can select from the concrete. We have this rectangular section. We have circular sections. We have concrete T sections. We have precast concrete I section. And for steel, we have I sections, channel sections, box or tube sections, and pipe sections. Similarly, for steel composite, there is circular encased I section, there is rectangular encased I section, there is filled up pipe section, and there is filled box or tube section. Now, these are some special types of cross sections that are not predefined. Like in case we have some non-prismatic beams. So we'll go for non-prismatic sections. If you have some section like say a plate girder or say a built-up section, we can use section designer for that. Okay, and there are some commercially available steel sections which is available in the auto select list. And general section is used for defining sections which have a very complex geometry. Okay, so I'll go with the simplest form of cross section, that is a a rectangular section. Okay, so for the column, I'll be naming them C 55 by 55. This name can be changed according to the type of the project or the type of the building. So generally, what I do is I name the column as C, and the cross sec and the width and the depth in centimeters. Okay, the first is the width and next is the depth in centimeters. Okay, now uh, this thing can be done, like the naming can be done according to the user as well. The material type as I defined will be M25 that I defined for the columns. Okay, so the depth will be 550 and the width will be 550. Now the figure over here, you see that the software automatically makes a cross section for viewing, right? It also shows us the arrangement of the rebars. Okay. Now I'll define the beam. I'll go with concrete rectangular. Similarly, I'll be using B for the beams and the width first, cross the depth in centimeters. Now I'll do it. Now this material will be M20 for beams. Okay. The depth, the cross-sectional dimensions will be 600 and width will be 300. Now there is a basic difference. Now you see that the cross section has already been displayed over here with rebars. Now for modeling beams, normally we do not predefine the rebars as such. Whereas for concrete columns, we need to RCC columns we need to define the rebars prior to the modeling. So we'll go to the reinforcement section over here, the modify show rebar. This will be a M3 design only. And the longitudinal bars will be HYSD 500 that we had defined earlier. And for designing, the clear covers also need to be mentioned here. So we'll keep it as 30. Okay. So now that we have defined the columns and the beams, we'll be modeling the beams and the columns in the window over here now. Okay, is everyone following me?
Yes, I was also saying that.
Yeah.
Any student, if you have any doubt or anywhere you left behind, you can again ask. We have run a 5-story building from the initial working setup you have seen. We have defined our materials and we have defined our column and beam sections till now. Any doubts, you can raise your hand or you can ask in chat. Otherwise, we'll move ahead.
Yeah, the column orientation, I'll be coming slowly. Okay. Okay then.
Local accesses you can tell, maybe 2 and 3 local access which we are
Yeah. I'll come to that.
Sure.
Okay, first let me just show how the modeling is done. Okay, then I'll come to the local access part of it. Okay. All right. Okay, now in the window over here, we have the plan view showing story number 5. Okay, so one quick way of modeling is to model the elements in plan view. So what I'll do is I'll go to the draw command, the drop down menu. Over here, I'll go to draw beam or column or brace objects. Okay, from here I'll select quick draw columns, plan or 3D. Okay, once I select this, a small menu pops up over here. The property has to be selected from this drop down list. that I had earlier defined, C55 by 55. Okay. Now, if you observe carefully, you will see that uh, from the draw command menu, the quick draw columns option is also available in the left side of the screen. We can directly access this command from here as well. So if I close this and again press it, you'll see that this command pops up. Okay, so now the main objective of drawing the grids was to locate the center point of the columns. Okay, this is the modeling here is basically center to center line modeling, right? So say we have a column here in grid 5A. So I'll just take the cursor over here and press it. So you'll see that the column is automatically created over here. Similarly, I'll go to grid B5 and I'll press the cursor again. You'll see that another column is created. Okay, you can go to individual grids and press the cursor, the left mouse button. You'll see that the columns are being formed. Okay, now even if you don't place your cursor in the grid, in any of the grids, and just press the left cursor button, you'll see that a column will be formed. Okay, so it's better not to model columns like this. It's better to have them placed along the grids. Okay, so again I'll take the quick draw columns option from the left hand side of the screen and I'll place them at the grids. Okay, so this is one way of modeling the columns from this menu. Otherwise, what we can do is we can make a window starting from the left to the right. The program automatically catches all the grid intersections and places a column there. Okay, so I'll press escape, or you can press the select object button. Then the quick draw column command will disappear. Okay, now I'll see. Now once you model it at once you model it in the plan, you'll see that the columns have only been modeled for that floor only. You go to the 3D view, you'll find that the columns are there only from the 5th floor to the fourth floor. So individually, we can go to each floors and model them separately. So how do we navigate from floor to floor? You go to this set plan view command. From the set plan view command, you can select stories as you wish. So I'll go to story 4 and again carry out the same exercise. But this time I'll make a window and place all the columns here. Okay. Now you can navigate the plan view using these move up list and move down in list buttons as well. So if I move up, you'll go to story 5. If I move down, you'll go to story 4. So similarly, I'll go to story 3. I'll go to story 3, make a window. All the columns have been modeled. Again, I'll go down in story 2, make a window. All the columns have been modeled. Then go back to story 1, make a window from the left to the right, and all the columns will be modeled. Now you go to the 3D view, you'll see that we have all the columns over here. Okay. So this is one way of modeling the columns for all the floors. Right. Now there is another quick way of modeling. If you just go to the bottom right corner, you'll see that there are two drop down lists and there is one units button. The units button will show you the units that are currently being used in the model, and this is the coordinates, and this is for one story and all stories. Now this drop down list can be used for modeling the elements quickly at one go. So what I'll do is I'll delete all the columns. Say I go to story 1. I select this drop down list, make it all stories. Now once I go to all stories, I can model the columns or the beams in one flow, and it will be modeled for all the flows. Okay, so I'll go to this again, the quick draw columns, make a window from the left to the right. And there you go. Okay. Okay, now next I'll come to the beams. Okay, for modeling the beams, I'll go to this draw menu over here, go to the draw beam, column or brace objects. Then I'll go to quick draw beams or columns. Okay. Now in this quick draw beams and columns, again, we need to select the property. The property I defined was B30 by 60. Okay. Now once you navigate the cursor in the screen, you will see that it automatically snaps to the grid lines. And once it snaps, you press the left mouse button, you see that beams are being formed. And just like the previous quick draw column command, you can make a window and get it done with. Okay. Now, since you have seen that the all stories command was active, you go to the 3D view, you'll see that beams have been formed in all the flows. Right? Okay. Okay, somebody had asked about column orientation. Okay, I'll just, before going to that, we need to first understand the global and the local axes. Okay, the x-axis in red, the y-axis is in y, and the z is in green, and the z-axis is in blue. Okay, this is the global axis. Similarly, we have the local axis, which is 1. 1 is for 1 denotes the x, then 2 denotes y, and 3 denotes blue. So this has to be noted down, especially while working with the local axis. You need to understand the color coding, because the color coding is used for assigning the loads or viewing the loads or changing their orientation as well. So if I go to the define menu once, we had defined the columns. So the column was C55 by C55. You see that 2 is denoted in green and 3 is denoted in blue. So this is similar to the global axis. The one is x, 2 is y, and 3 is z. Okay, so for changing column orientation, I'll define another new column. Say C40 by C30. Okay, so the depth will be 400 and width will be 300. Okay. Okay. So what I'll do is I'll go to the plan view, story 5. I'll select one column. Now all stories are selected. So all the columns in all the floors will be selected. I'll delete it. Go to the quick drop columns command. Go to C40 by 30. Then model it. See, now we can change the orientation of this column by selecting it. Go to assign, frame, local axis. Okay. Now general orientation applies to all frame objects. I'll rotate it by 90 degree. Okay. So now once I've rotated it, you see that all the local axes are now active. Okay, as you had seen that 2 and 3 were there in the cross section, and 1 is along the height.
Is there a shortcut to see the local axis orientations?
Yes, it is available. I'll come to that. I'll come to that later on. Okay, so is everybody following what I'm doing?
Maybe till previous one they must have followed.
Yeah.
The change of column they must have not till now.
Okay then. Okay. Okay, there is another way to change the column orientation, right? With whatever commands that we have used till now. Like we go to the define menu, we go to section properties, we go to frame sections, right? I had defined the C40, sorry. So C40 by C30 column, right? I'll just change the width and the depth.
Yeah.
Okay. So in that case also, if you see your column orientation has changed, right? Now, once I model it, like I'll go to frame sections again. Okay, I'll define one column with 300 width and 400 depth, and another column with 400 width and 300 depth, and I'll model them to show that how the orientation is being changed.
Maybe what we can do, we can keep this first example is very simple, as we were doing with a certain same size.
Yeah.
Next example we can do, because everyone can get this.
Yes. Yeah. I think that will
better. It will be better. It will be the first example which we kept. No?
Yes.
Keep it
Okay.
as it is.
Okay.
All the columns and all the beams are of the same size.
Yes. Okay. Fine. So now we have defined the frames for the entire structure. Right. Next,
everyone is everyone till here making with us? I hope all of you have made this frame where we have a set column size and where we have a set beam size. We have just created that grid, 5 by 5 grid of 4 meters distance each. So we'll go ahead from here. If anyone has any queries still here, please raise. Otherwise, we'll go ahead. Okay, Anvesh, let's go ahead.
Okay. Okay. Now, once the frames have been defined, we'll go to defining the slab. Okay. So we have slab sections. We'll go to slab sections. We'll go to the define menu. From the define menu, section properties, we'll go to slab sections. Now we'll add a new property. Okay. So I'll name this slab as S150. Now, keeping the slab material as M30, we can also change them as we feel like or as per the design requirement. Then the modeling type will be membrane. The type will be slab. We can also model drops, stiffs, ribbed, waffle, mat, or footing. We'll go with slab now, as we are modeling slabs. The thickness will be 150.
You can maybe tell where membrane and where we use thick or thin slab shell or layered shells. Where these different modeling types we use, in which cases?
See, membranes are basically used for transferring the vertical forces on the slab to the frame elements directly. Okay, they do not have this out of plane stiffness. Okay, like whatever say dead load or live load we apply on the slab, that will be transferred to the beams as per the load distribution mentioned in IS 456.
Yes, direct as per the area of the.
Yes, the tributary area.
Tributary.
Okay. Yes. So now, in some cases where we need to say design the slabs as well, we'll go with shell. Okay, shell thin or shell thick. Now, shell thin is basically it basically what it does is it is a it is a shell, it is a slab where the bending is predominant. Okay, and shell thick is used where your shear forces are also very high, like in the cases
deep slabs.
Yes, yes, deep like deep slabs or say corbels, or even in some cases where the shear forces are very high. Okay, for that cases we'll be using shell thick.
Okay.
Okay, and layered is for non-linear case. All right, that is for non-linear analysis. So for a simple building, we'll go with membrane.
Okay.
All right. So we have defined the slab section now.
Thickness we have kept 200.
No, thickness we have kept as 150. Okay. So I'll press OK. Now my slab has been defined. So first thing what I'll do is I'll make this all stories to one story and go to the draw menu again. Now here I'll go to draw floor or wall objects. Now the program gives us quite a few options. Okay, this is like say draw floor, wall or plan. Now here in this case, if I select I'll go with the easiest one first. I'll go with the quick draw floor or wall command. So here, once we select this, we need to again change the property, make it S150 that I had defined. And when we take the cursor in between the beams, it automatically selects the slab area by highlighting the beams. So if I press the left mouse button, the slab is created. Okay. Similarly, we can again make a window starting from the left to the right and define the and model the slabs. Similarly, we can go to the fourth story, make a window, model the slabs, use the move down in list to go to the third floor, make a window, model the slabs, or we can go to story 2, make a left to the right window, model the slabs, go to the first floor, make a window again, and model the slab as well. Okay, Now you can see from the 3D view, now if you use this button over here, the rotate 3D view, you can rotate the 3D view to view it from various angles. Okay. Right. So I think this simple model creation, this is only the geometry. I've created only the geometry at first. I hope that people are being able to follow this. Then I can go ahead to some other different model.
Is it all right for everyone? I hope everyone has understood.
If it is becoming too basic, also then I can.
Yeah, we can go ahead. This
Right?
this people have understood. Yeah.
Okay, fine. Okay. Okay, then now the next exercise will be to having different types of columns. Columns are different sizes with different orientations. Okay. So I'll go to the define section properties. I'll go to frame sections. I'll add a new property. Concrete rectangular section, M25 columns, C35 by 550. Depth will be 550. This will be 350. Okay. Okay. Beams I'm keeping the same. Okay. Now I'll make use of another command that I had explained earlier. I'll go to the select menu. As I had said, select menu can be used to select some particular type of properties. Like say, if I go to frame sections, I can select the columns that I had earlier defined, the C55 by 55 columns, and say I delete them. Okay. Then I close this method. I'll go to the plan view, go to story 5. Then I'll activate the all stories option. Then I'll go to quick draw columns. I'll select C40 by, sorry, C35 by C55. Now I've selected the all stories. I'll make a window from the left to the right. And you have seen that all the columns have been created. Right? So now I want to
Columns
change.
are already rotated because we have
Yes.
done the axis rotation once.
No. That I had defined it like this. I had defined it like this. Now I'll go to say section properties. I'll go to frame sections. I'll go to say I'll define another property. Say C55 by 35. I'll go to 550. Sorry, 350 by 550. Okay. Now, since all stories are command is already active, I'll say select one column from here. Okay, I'll delete it. Quick draw. Now this angle degree will be 0. I'll go to C 55 by 35. Okay, you can change the angle from here, the angle, the degree over here, and place it like this. Okay. Or else another way is, like I had mentioned, select the column from here, go to assign, go to the frame, go to local axis, rotate by angle 90 degree, and then you'll see that the column rotates by 90 degree. Okay, you see that the orientation has changed. Okay, now since we have done this basic practice, Tanmay, I'd send you a mail.
Yeah, I'll share
I'd
the
send-
link with all of them.
Yeah, we can start modeling that.
Okay, I've created a Google link for that. So I'll share that link with everyone in the chat itself. So everyone can try to open this link. We have been given a CAD file. Please let me know if this CAD file is downloadable. Anyone is having any trouble, let us know. And we'll try to draw this geometry. Someone can respond if this file is downloadable or not. Okay, so let's try to draw this geometry. Open in your CAD.
So as you can see from my screen, this is a typical floor plan for a building. So here all the column sizes are 500 by 500. All the main beams are 300 by 600. All the secondary beams are 230 by 500. Right. So we'll be modeling this. Now all the grid spacings are also typical over here. But I will be adding some secondary grids as well for the secondary beams over here. Okay, and let's start with this. So I'll go to a new model. Use built-in settings is already selected over here. Okay, so the previous time I'd used the uniform grid spacing and the simple story data. I'll be using, hello?
Yes.
Okay. Okay, I'll continue. Okay, I'll go with this custom grid spacing now. I'll go to edit grid data. Okay, so we have this. We have the grid system name G1. Okay, the alphabetical grids are along the y-axis and the numerical grids are along the x-axis. Right. So I'll open the drawing again. we have A, B, C, and D. Right now, as you notice, the secondary beam over here is 2 meters from grid A. Okay, so I'll be naming it as A dash. That will be 2 meters from grid A. So A is 0. I'll start with, that is A with 0. Next will be A dash, will be 2 meters. Then B is actually 8 meters from A. So B is 8 meters from A. Then we have C. C grid is 16 meters from A. Then I add another grid, that is grid D. Now, before I go to grid D, there is another secondary beam over here, that is 3200 from grid C. Okay, so I'll be adding a C dash grid, that is 3200 or 3.2 meters from grid C. And then we have finally, sorry, not finally, then we have D grid, which is again 8 meters from grid C. Grid D, which is again 8 meters from grid C, that is 16 plus 8, 24. And then we have grid E. Grid E is again 8 meters from grid D. 8 meters from grid D. Okay, so we have made the grids along the y-axis. Now we'll start with the grids along the x-axis. Right? Here we see that now we have taken this as 0 and grid 5 is starting from 0. So we need to change the order of the numbers over here. We need to make it 5, 4, 3, 2, and 1. So we'll start with 5 at 0. 5 is at 0, then 4 is again 8 meters from 5. 4 is 8 meters from 5. Then we have 3, which is 16 meters from 5 or 8 meters from 4. It is 8 meters from 4. Then we go to grid 2, which is again 8 meters from 3. Grid 2 is 8 meters from 3. And then the last, sorry, second last, we have a secondary beam over there. So we'll be naming it 1 dash. 1 dash is 2 meters from grid 2. 1 dash is 2 meters from grid 2. Okay. Now next we'll be having another grid over here, that is 1 double dash, that is 2 meters from grid 1. So I'll first define grid 1. Grid 1 will be 8 meters from 2. I'll be defining 1, which is 8 meters from 2. 2 is at 24. Next is 1 double dash. 1 double dash is 2 meters behind 1. So we have 1 over here, which is at 32 and minus 2. So it has been defined. Okay. So this like addition, subtraction, these calculations can be done over here to define the grids. Okay. So now grids have been defined. We'll go to the custom story data. We'll not be using the typical story heights now. I'll go to edit story data. Okay. I'll make this building also a 5-story building. I need to add another story. So I'll do a right click over here at this arrow. I'll go to add story, keep existing story heights. I'll keep the story height as 3, insert above story 4 from existing story 4. Okay. So story 5 has been created. Now story 1, the height of story 1 is basically the founding depth. So I'll keep it as, say, 2 meters. And this time what I'll do is I'll be modeling each story having different heights. So this will be 3.25. This will be 3.5. This will be 4 meters and this will be 3. Okay. 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 I'll close the 3D view and I'll work on the plan view. So we have column sections 500 by 500 and beam sections 230 by 500 for the secondary and the main 300 by 600. So before I define these sections, I'll be defining a material type. I'll go to define material properties, add a new material. Material type will be concrete. Material grade will be M25. Okay. I'll change the weight to 25 to make it more accurate. Okay. I'll define the rebar as well. HYSD 500. Okay. Now, once the materials are defined, I'll define the columns first. I'll go to add new property, concrete rectangular section. I'll name the column C50 cross 50. The material grade will be M25. Both the sizes are same. Okay. Now I'll define the primary beam, add new property, concrete. Beam will be 30 cross 60, M25, 600 by 300 is the width. Now I need to change the design type from column to beam. Rebar materials will be HYSD 500 and the cover will be 30 mm. Okay. Now I'll define the secondary beam. Secondary beam was 230 by 500 and 25. I'll name it as SB 230 cross 50, depth 500, width will be 230. Modify rebar, change it from column design type to beam design type. Longitudinal bars will be 500. Confinement bars, make it 415. Okay. See, now in the previous model, it was quite, the grid spacing was quite regular. But here, we are secondary beams. The grid spacing is actually regular, but we have secondary beams. Just to locate that, I've added some more grids that will help us to locate them. Okay, so first thing, we'll start by modeling the columns. There is a column along on grid on 5A, 5B, 5C, 5D, and 5E. Okay, so we have 5A, 5B. If you just take it, if you just take your cursor to the grid intersection, it shows you grid B5. Then we have C5, D5, and E5. So I'll go to the quick draw column, select the property, go to the individual grids, and then we also have a column over here, column line. You can just directly then we have a column along grid 3 as well, column line. Now we have 3 rows of columns for grid 2 and grid 1. So grid 2, and that's grid 1. Okay, so we have made the columns for story 5. Now there is another edit tool that I would like to show you for faster modeling. We'll select all the columns over here. You can see that in the the bottom left corner of the screen, we are showing 21 joints and 21 frames selected. We'll go to edit. From edit, we'll go to the replicate command. Now, the replicate command, we can use it to make repetitions of the same object, either in the linear direction. We can make it we can make repetitions of this that we have just made along x-axis, along y-axis, or we can make it in the radial direction, or we can mirror it, or we can repeat it story wise. So I'll select the story tab over here, and I want to make it for all the stories. So I'll select from story 4 to the base and apply. Now you go to the 3D view, you can see that all the columns have been created. Okay. So I'll close it. Again, I'll go to the plan view, story 5. Now we'll draw the beams. So for drawing the beams, you go to the draw command, draw beam. I'll use this draw beam or column brace. This is another way to draw your frame objects. The property will be 30 by 60. Now by using this command, we can draw beams anywhere, actually. The quick draw snaps it to the nearest grids, but by using this command, we can just draw the beams randomly. This command gives us a better freedom to work. So I'll select this command. The property is already selected. Now I'll draw the primary beams. Now, while modeling, it's always better to draw the beams along one axis first. Okay, so once the primary beams are made, I'll see where the secondary beams are located. We have one secondary beam along A dash grid, which is between grid 3 and grid 2. The secondary beam is 230 by 500. This is between grid 3 and 2, and this is between grid 2 and 1. Sorry. The beam along C dash grid is between 5 and 3. So it's between 5 and 3. And the rest two are between grids 1 and 2, located at grid 1 double dash and grid 1 dash. Okay. So now our framing plan for story number 5 is complete. Now we need to repeat it for all the other stories as well. The columns have already been created. So now I would like to select the beams only. So I'll go to the select menu over here, go to the select command. We go to the object type. We can select object, we can select our elements from the model by various means. We can select them through object type, through properties, either through the material properties, the frame sections, the slab sections, deck sections, wall sections, the link sections, the link properties, point springs, line springs, area springs, labels, groups, stories as well. We can even select stories. Say I select story 5. So all the elements in story 5 have been selected. Now I don't need all the elements over here. I need only the beams. So I'll go to select, go to object type. Now since beams are only available in story 5, if I select beams over here, only the beams of story 5 will be selected. Again, what I'll do is I'll go to edit, go to replicate, story. This will be from 4 to 1. Applied. Okay, so you can now go to each and every floor and check it out. This is story 5, this is story 4, story 3, story 2, story 1. Fine. Okay, now what you're seeing beneath the columns over here, you're seeing a rectangular, sorry, you're seeing a triangular object being created over here. These are the support conditions. Now, initially, the support condition is taken as hinged. We can change them as we desire. We can go to, so what I'll do is we'll go to the plan view, go to the base, select all the supports to the window, go to the assign menu, go to the joint, restraints. So currently we have restraints for the translations along X, Y, and Z. So there are some predefined fast restraints, like this is the free, that means no restraints. This is the roller, so you have a restraint along the translation of Z. Then we have the hinge support, where translation is restricted along the three axes. And lastly is the fixed, where the translation and the rotations along all the axes are restrained. So we'll be making it fixed. Okay. All right. Now there is a extruded toggle view option, which can be turned on for viewing the the extruded toggle view can be used for viewing the elements in 3D, where the thicknesses are also viewed, also shown here. All right. Okay. Next, what we'll do is we'll be defining the slabs. So I'll go to define section properties, slab sections. Add a new property, make this M25, go for S150. Modeling type will be membrane, and the thickness will be 150. Okay. Okay, I'll now use this quick draw floor or wall. The property will be S150. As you can see, from the cursor, it is snapping to the grids, sorry, the beams. So I'll just model them. Okay. So again, I need to make this for all the floors. I'll go to the select. I'll go to the object type, select the floors. Then make it up to story 2. Okay, so the basic geometry is now complete for this model.
Everyone is with us. Have you done the basic modeling? Is there any doubt in basic modeling, anyone? Maybe we can go ahead with loadings and
Okay, fine. So I'll now go to the next step, that is the loads. Okay, I'll go to the load patterns over here. The load patterns are used for defining the various loads that we have on the structure. Okay. So the dead and the live loads are already predefined over here. We can also add some other loads of our reckoning, like in the sense we can have, say, brick wall loads, which will be of the type dead, but it is to be kept in mind that the self weight multiplier will be 0. Then we can have, say, terrace live for the roof live loads. To make it live, add new. Okay. So
We
I'll
can,
now,
we can we again repeat from the loads from the start?
yeah, we'll go to the load patterns. We'll go to define, the define menu over here, and go to load patterns.
Yes.
Okay. So previously we have there are some predefined loads already, like dead and live is already predefined. Okay. Now for our working, we can also define some other load types. Okay, like I made a brick wall for the dead loads, for the brick wall loads, and a terrace live for the terrace loads. Okay. So now I'll show you how the brick wall loads are applied to a model. Okay, so I'll go to, say, the plan view, story 1. Now the brick wall loads, or say the loads from the partition walls, they are basically modeled as frame loads in ETABS. So for assigning them, what we need to do is first select a frame, then we'll go to assign frame loads. Now frame loads, we have several types of load assignment options over here. We have point loads, we have distributed, temperature, and open structure wind parameters. So we'll go first with the point load. Okay, this is just a brief, just to show how point loads are applied. Okay. Now, see, from here the distances here are shown in relative. Okay, we can apply forces here, we can apply moments here, and the direction of load application can be based on the type of load that we apply. So normally dead loads are applied as gravity. Now if there are some lateral loads acting in some other directions, we can use the global XY, or we can go with local 3, 2, or 1. Okay, now to view a local axis, say there is this beam over here. I want to view the local axis. The global axis is already visible over here. The X, the Y, and the Z. Now to view the local axis over here, what I need to do is I'll go to this tick button over here, the set display options. Now in the set view options, I'll go to object assignments. Now in the frame assignments, you have the local axis. I'll select the local axis and press on apply. Now the local axis for all the elements are visible over here, and they are marked as well. The red is 1, this is 2, and this is 3. The blue is 3. Okay, now to turn this off again, I'll have to go back to set display options, go to object assignments, turn off the local axis, and press apply. Okay, now say I need to define a load over here, sorry, assign a load over here of 10 kilonewtons, which is coming from, say, some sort of partition that is supported on this beam. So first thing I do is I select the beam. After selecting the beam, I go to the assign command, go to frame loads, go to the direction of the load application will be gravity. Now the gravity here by default is taken as negative z axis. So if there is any vertical load, that is
I'm sorry, there was some connection disruption over here. Can you again go with the distributed load?
yeah, I will go to see. Say I need to apply a distribute say a UDL on this frame element over here that is selected. Okay, say having value 10 kilonewton per meter. So I need to select this beam, go to assign, then go to the frame loads option over here and go to distributed. So frame load assignment, you'll see a window opens up, frame load assignment, distributed type.
Yes.
Now the direction of load, now that load type and direction. So what I wish to do is I wish to apply a UDL.
Yes.
So UDL will be a force and the direction of the load application will be gravity. Gravity by default in ETABS means negative z direction.
Yes.
Right. So say I need to define a UDL of 10 kilonewton per meter. So I come to the uniform loads option over here and I give a value of 10 kilonewton per meter. Okay. And I press apply. Okay. So you'll see now that a UDL has been created on this frame to the tune of 10 kilonewton per meter.
Yes.
Right. Now we can also play with the direction also. Now say I select this. I select this frame object over here and say I need to assign some sort of an upthrust force on this frame element. So as I had mentioned that gravity is by default taken as negative z. So if I take it as negative 10 kilonewton, it will be applied as an upthrust.
Yes.
Okay. So we can also assign the UDLs in other directions as well. Okay, I need to apply some lateral load over here, say which is along global y-axis. So I change the direction of load application to global y and say change the load to 5 kilonewton, press apply. Now a load has been applied along a UDL has been applied along the y-axis for this frame element. Okay. Now similarly, we can also apply trapezoidal loads on the frame elements. say I apply a trapezoidal load with 20 kilonewton per meter on one end and 5 kilonewton per meter on the other end. So 25. Now in between, what we need to do is we need to specify the trapezoid over here. So we need to mention the load that will be applied at 0.25 from the start of the frame
We
object.
just write 0 and 1 as distance, and 3 and 4 we keep blank.
No. We can't leave that blank.
3 and 4 we cannot leave blank, and we have to
No,
give any ways.
No, if we leave it as blank, what will happen is,
Yeah, there that 0 we are seeing
yes.
distribution.
So that trapezoidal distribution will not be there. Okay, we'll be
Yeah.
having triangular loads.
I'm saying if
Yeah,
on
yeah.
distance you write instead of 0.25 you write 1.
Okay. So there are actually two options that can be used for modeling. One is this relative distance from end one. When we have this relative distance,
then you have 4 grid
the
points to
program
select.
automatically makes it 1/4. Okay,
Correct.
like it divides the frame into 4 parts, and we need to provide values at every 1/4. Okay. Otherwise, what we can do is we can go with absolute distance.
Yes.
Okay. If we have this absolute distance over here, we can even have this triangular loads up to the desired extent.
That distance. Yes.
Yes. Okay. So in that case, we need to know what will be the length of this frame element.
Correct.
Okay. Now one more thing I just need to tell, like, say I need to, after modeling this, I need to see what is the property of this, what is the section property, or what is the length. Okay. Or what other properties or loads have been applied on it. How do I view it? What I have to do is I have to select this frame, right click on this frame object. Now a window pops up. Having the name beam information. So here we'll have all the details. We have the assignments like the section property. We have property modifiers and releases and lots of other information over here. Then we have the geometry, the first tab. The first tab is the geometry. Okay. So here we have the length of the beam. Okay, and the end I and the end J. End I is nothing but the starting point of the beam, and end J is the end point of the beam. Like I had earlier told you, while modeling a beam, we need to follow one single pattern. Like while drawing, like first we'll draw either say from starting from the origin along the y-axis, then from the origin to the end of the x-axis. So when we follow one pattern, it becomes quite evident to us which side is end I and which side is end J. So in this case, I know that end I will be this side because I started modeling the beams along x-axis from the left to the right. Okay, and then this loads tab is also there, where we can see what all loads have been applied on it. I had just applied a load over here, a trapezoidal load, so that has been applied. Then these are the design procedures and the design overrides. We'll come to this when we go to the design. Okay, so now what I'll do is I'll show one trapezoidal load.
15, 10, 5. Then you can do 0. It's a triangle trapezoidal solution. Okay.
Okay, you can also do it from 0. In that case, it will be this will be a triangular load.
Yeah.
Yeah.
For trapezoid, you have to start from 0.
For trapezoidal, we can do is for trapezoidal, what will be? Yeah. For trapezoidal load, say we have a load where one side is 20 and the other side is 5.
Okay.
Okay. So in that case, your you'll be having 5 throughout, and 15 will be. So this is the trapezoidal loading. Okay, we just need to find out what will be the load points at 1/4, 3/4, and the end span.
Yes.
Okay, then I'll come back to story 1. Now I'll show how do we apply point loads. Okay, say there is one. Say that I need to apply a point load on this beam. So I'll go to assign again. I'll go to frame loads. I'll go to point. Okay. Now say I need to apply a point load at the center. Okay. So what I'll do is I'll go to the absolute distance from end 1. Okay. A singular point load at the center of the beam having 50 kilonewtons.
Okay.
In the direction of the gravity. So I select the absolute distance from end 1, make the distance 4 meters, and the load is 50. Okay. I'll go back to the 3D view. Now you see a point load has been applied on the beam. Okay. Okay. Okay, then fine now. Now what I'll do is I'll show you how the beams, how we generally apply loads for say the partition loads on the frame elements. So what I'll do is I'll go to the frame loads, go to distributed, the dead. Now this will be 0 since I don't want trapezoidal loads over here. I'll go to brick wall. Now say I have 20 kilonewton load as the partition load.
Okay.
Okay, so 20 kilonewton has been applied as partition loads over here. Okay, fine. So now I'll apply them, say on the exterior walls. I'll go to frame loads. I'll select all the beams first. Then now I'll apply the brick wall loads, which is already defined over here as 20 kilonewton per meter. direction is gravity. The load pattern type is brick wall. Okay. Now press OK over here. I'll go to the 3D view again. Rotate 3D view. Zoom in. Now we can see that all the frame loads along the perimeter has been applied.
This
The
can
similar-
be used to replicate.
Yeah.
This can be also used for replicate command.
Replicate command can be used for repeating geometry, not for
Not
repeating loads.
Okay.
Okay. Now say if your beam section in the first story over here is same in all the floors, and the partition loads are also same.
Same.
Then what we can do is we can use the replicate command to replicate the beam in all the floors. By now, once we replicate it, these properties will be transferred to the respective floors.
So load will also be transferred.
Yes, the load will also be transferred.
So better to create one floor first,
Yes.
with complete loading, and then if
Yes.
it's the same, then we can replicate.
Yes, because normally in buildings we don't have such repetitions except for the exterior walls in some cases. All right. Okay. Now, by default, when we model frame elements in ETABS, there is complete rigid connection. Rigid connection in the sense all your moments, all the moments and the forces, means the moments, forces, the twisting moments, shear forces, all will be transferred through the joints. Now, in case of secondary beams, that is not the case normally. Normally, what we do is we design them as simply supported.
Yes.
So we need to release the moments. So what we do is we'll select them. Okay, first I'll show for one. We'll select this beam over here. Go to Assign tab over here. From the Assign tab, we'll go to the frame portion. Now, when you scroll through this menu, you will see that there is a releases or partial fixity command over here. Okay. Now, here we can, the program gives us option to release axial loads, shear forces, torsion, moment along the major axis and the minor axis. Okay. M33 is the moment along the major axis, and M22 is the moment along the minor axis in this case. So what I'll do is I'll release these moments. Apply. Now you will see that there is a
hinge kind of formation.
Yeah, there's a internal hinge kind of a thing developed over here. Okay. Okay, now I'll go back to Assign, go to the frame command, and again select releases partial fixity, apply, and then this will be created.
In 3D, is there a way to see them?
Yeah, you can view it.
Yeah, similar way, correct.
Yes. Okay, now say what I do is whenever we apply some changes to the model, right, it is initially visible, but if I press this show undeformed shape, the changes that I made, that will be gone. All right. Now say there was some beams where the moments were released. Say over here. Now I need to view them again. Okay. What I'll do is I'll go to the set display options.
Okay.
From the set display options, I'll go to the object assignments. From the object assignments, I'll go to the end releases.
Or
Okay, then I'll press apply. Now you'll see that the moment releases have come back again.
come back.
Okay. Now this window can be used for viewing multiple things.
Mhm.
It can be used for, say, viewing what sections have been used in the model. So I'll press on sections, press apply, and the sections that I've used over here are visible. Okay. Now this is only for the frame assignments over here. Similarly, we have for the shell assignments. Say I need to check the thickness of the, like what section property that I've defined in ETABS have been used as slabs over here.
Yes.
So what I'll do is I'll deselect this. I'll go to shell assignments, press on sections, apply. So we can see that the sections are also available. For better viewing, we can go to the plan view. Say story 5. We can see what all has been used as slabs over here. Okay. Similarly, we can view the local axis for the shells also through this set view options. Press on the local axis, press apply. The local axis are viewed over here.
Yes.
Okay. Now, if I press OK, this information will be available to us for whatever operation we carry out.
While making secondary beam, if someone has made beams into two parts, say from grid to grid in small parts, how can we join back to make it a whole beam?
Okay. Okay. So, say this is
In two
okay.
parts.
I'll show this how like beams can be broken and beams can be joined.
Join.
Okay. Yeah. Okay. Say this is the beam that I want to divide. So I
Yes.
select this beam. I'll go to edit. Okay. Now I'll go to edit frames. Then I'll go to divide frames. Now we can divide the frames. There are 3 options over here. We can divide it into, say, multiple number of objects,
Yeah.
or we can break it at with selected frames and joints, or break at intersection with visible grid lines. We'll explore all the 3 options over here. Okay. The first one is, say I divide it into 2 objects. So I'll select it, make it 2, apply. Now it has been divided into 2 objects. If I select this beam now, we'll see that in the bottom left corner over here, it is showing 1 joints and 2 frames selected.
Yes.
Okay. Okay. Now what I'll do is I'll close this. I need to say join this frame again. I'll go to the edit menu, open the edit frames menu, join frames. Now it has been joined. And I select it, only 1 frame selected. Okay. All right. Now the next option, I can divide it into multiple number of frames. Now there is another option. Say I need to divide it at a distance 1.5 meters from grid A-3 point.
Mhm.
Okay. So what I'll do is this is the first time that I'll be using a joint object. Okay. I'll go to the draw command. I'll select the draw joint objects. Now, while using the draw joint objects, it shows plan offset X, plan offset Y, and plan offset Z. Now I'll be drawing the point over here. I need the intersection at 1.5 meter from this point. So it is along Y axis. So I'll be writing 1500 mm. This is in mm. Keep it in mind. So if I draw an object over here, joint over here, the joint will be created exactly at 1.5 meters from this point. Now this can be verified by, if you just take the cursor at this point, you'll see some coordinates are being shown over here.
Yes.
Okay. Now see the coordinate over here. This is y equals to 16. Once I bring it here, this will be y equals to 17.5. So we can verify dimensions of the elements using the coordinates given here as well.
Mm.
Okay. So say I need to divide this line now. So I'll select the line, I'll select the joint, go to edit frames, divide frames, break at intersections with selected frames and joints. I'll press apply. So once I've applied over here, you'll see that 2 frames have been created over here from this joint onwards.
Yes.
All right.
Yes.
Okay. There is now another. Now say there was a secondary beam along grid 1 dash.
Mm.
Okay, I'll join this frame now. Edit frames, join frames. Okay, I'll delete this joint.
Mm.
Say that there was a secondary beam over here, and I had to divide it into 2 frames. Okay, along this grid line, that is A dash.
Okay.
Okay, so first I do is I have a secondary beam over here. Okay, I select this beam, go to edit frames, then go to divide frames, break at intersection with visible grid lines. Press apply.
Okay.
Now you see that the frame has been broken into 2 parts.
Mm.
Wherever there is an intersection with grid line, we'll divide it.
Right.
Okay, so I'll join this now. Go to edit frames, join frames. Okay.
Correct.
Okay. Now there are some other options as well, like that can be explored through this edit menu. That is, say, this align joints. We can use this command for extending frame objects. Okay, say we have this beam here, this secondary beam here, okay, which needs to be extended to, say, D.
Yes.
Okay, so we have a frame over here. We have another frame over here along D.
Okay.
Let us just assume that we don't have any other grids along D. Okay, and we have whatever we have, that is up to C. Now we need to extend this line up to this line. Okay, so what we need to do is we need to select this line as well.
Sorry to interrupt in between.
Yeah.
Is this grid frame you have created, is it till grid D or is it little bit far behind? Because it is happening sometimes.
For to remove the confusion, let me draw a line over here. I think that
No,
will be,
otherwise it is happening while making frames. It is not going up to the grid. It is just besides the grid, maybe some centimeters away it is remaining.
This command will work in that case as well. Say I have a frame here where we don't have a grid.
Okay.
Okay. Now I need to extend this line up to this line. So okay. So what I'll do is I'll select this line, and this line will be extending after this joint. So I need to select this joint as well.
Hmm.
Right. Now I'll go to edit. I'll go to align joints, frames or edges. Now extend frame objects. Press on apply. So this will be extended till here.
Correct.
Okay. So this is another option this is another edit tool that is very useful. Okay. All right. Now say there is another, a change comes up in the drawing and you need to move this secondary beam from here to here.
Hmm.
You have already modeled this beam over here. You have given the loads on this beam. You have provided the moment releases and all that. Now this has been changed. The location of this beam has been changed from here to here. So what we'll do is we will move this beam object from here to here. So we'll go to edit. Now move joint frames or shells. Okay. Now say we need to move this beam object by 8 meters. If you have the dimension, that's okay. We can mention it over here, and that will be along the x-axis. So 8 meters. Apply.
Right.
Okay. If now say if you don't have the dimension with you, but you have modeled it, okay, and you're in some sort of a hurry, what you do is you go to pick 2 points on a model, go to this point. You're taking this point from here to here, then press on apply. Sorry, the object was not selected. Yeah. So you see that it has moved.
Yes.
Similarly, now we can move it. Say it is to be moved in some say orthogonal direction. Yeah.
Mm.
Okay. So I need to take it from here, say till here. I press apply. This object will be moved from here to there.
It has snapped on grid.
Yeah. Okay.
Understood.
Okay. Okay, then let's see what other options are still there in this edit button. Okay. All right. Now say you need to change your grids or say the floor heights due to some changes in the drawings or something like that. So we'll go to this edit story and grid system data. Here we have the story data, which is shown over here, and we have the grid systems shown over here. If you need to change the story data, we'll go to modify, show story data, and this story data pops up. Say we need to change some story heights or say add an additional story.
Correct.
We can do this over here. Okay. And similarly for the grid systems, if you need to modify the grid, we can go to the modify grid. The grid system data shows up. We can change the grids from here.
Yes.
Okay. Then the next thing over here.
These are
Now-
self-explanatory, most of the edit tools.
Yeah.
These are most of the self-explanatory.
Yeah, these are most of them are self-explanatory over here. Okay. Then edit shells, like say dividing shells. Now we have to say divide shells into multiple shells over here. Then this command can be used. We can go to edit shells, divide shells. Okay.
Similar
This
to
can be-
frames.
It is similar to frames. Okay.
Yeah.
Then we can divide it also using say frame objects, then visible grids and joints. All right. Okay.
Then you can tell about the property modifiers when we have
I think
less than
that
column. That will be next, maybe.
Yeah.
That can be.
Hello.
Yes, Anish.
Yeah.
So I guess let's keep it till here today.
Yeah. Let's keep it till here today.
We'll see property modifiers, other joint loads, and then how to analyze and how to see the results
Yes.
for basic gravity loading, and then we'll introduce
Yes.
various lateral loadings.
Hello.
Yes.
Yeah.
So any doubts from our participants?
Okay then. Yeah.
If anyone has any doubt till here, we have shared the drawing which we are doing with you. Please try to come up till here so that in next class we can build over this, or whatever basic editing and basic
Yeah.
creating doubts you have.
They can practice on their own, and if
Yes.
any doubt comes up, we can address that tomorrow.
Yeah. So tomorrow we are meeting, or day after tomorrow we are meeting?
Day after tomorrow.
Yeah, day after
Yeah.
tomorrow. Yeah, Lakshya. So thank you very much for this first session. Let us meet again on 21st. Everyone will be here by 4, and we'll go ahead because today was very basic for some of them who have done it already. And for the new users, they have come to the platform of editing and understanding basic concepts of beam, slabs, and columns. So thank you once again, Lakshya, and thank you, Anvesh.
Thank you.
Thank you so much. Thank you, Dhanvi. Thank you, everyone.
Thank you.
See you.
Thank you.